In this video clip, we're going to look at equivalent ratios. When we have equivalent ratios, we're thinking about things that can be equal to. So with an equivalent ratio, I want you to think of equivalent fractions. They're going to work the same way. So if I have a ratio of 1 to 2, and I can write this ratio in 3 different ways, 1 to 2, or 1 to 2. I want to look at how I would take the fraction form and write equivalent ratios for that. If I start with 1 to 2, I want to build this table and make equivalent ratios, just like equivalent fractions. I would start with a multiplied 2 on the top. If I multiply by 2 on the top, I multiply by 2 on the bottom, and I would get 2 out of 4. 2 to 4 is equivalent to 1 to 2, just like a fraction. I can continue to build, but I always want to go back to my beginning ratio, which we learned was a base ratio because it is the reduced ratio. I'm going to use this ratio in build and now say multiply by 3, and 1 times 3 is 3, and 2 times 3 is 6. I am building a table that has equivalent ratios. I can continue to build, but I always go back to my base. And let's write another one. Go back to my base, but this time I'm going to multiply by 4, and 1 times 4 is 4, and 2 times 4 is 8. This multiply by 2, multiply by 3, multiply by 4. When we say multiply by, and then put a number in there, we're going to consider this to be a scale factor. It's what we're enlarging by. We're increasing our ratio by a scale factor. Are we making it 2 times greater, 4 times greater, or even possibly 5 times greater? If I made it 5 times greater, that means my scale factor would be times 5. Multiply by 5. If I say 1 times 5, I get 5. 2 times 5, and I get 10. So if my scale factor is 5 times larger multiplied by 5, I'm increasing it 5 times. So it's 5 times greater. With equivalent ratios, it also helps us find missing ratios. So let's talk briefly about missing ratios and how we can find the equivalent to that missing ratio. It's like setting up an equivalent fraction. I could have 1 to 2, and I know that it's equal to something out of 6. I am just looking for what this top number would be to make it an equal or true statement. So I use a scale factor. In other words, what am I multiplying by? Scale factor to get from 2 to 6. So I'm thinking of my math facts. 2 times 3 is 6. If I do it to the bottom, I do it to the top. 1 times 3 is 3. So this is an equivalent ratio, and we have found the missing number to make the ratio a true statement. Let's try one more. What if I had 9 to 12, and I know that it is equal to something out of 4? This time, I am not multiplying by, but I'm going to be scaling down, so I have to divide to go down. What can I do to 12 to go down to 4 and scale this ratio down? I can divide by 3. If I divide by 3 on the top, I divide by 3 on the bottom, and we get 3 out of 4. So whatever I do to the top, I do to the bottom. And it's an equivalent ratio, not an equivalent fraction. We now use the word ratio to describe these numbers that we are comparing. We'll be talking more about this in class. Please come in with your notes so that we can discuss what happens next.